Am I audible? Can anyone just respond? Am I audible or not? Yeah, fine. So just wait for 1 or 2 minutes more. Let's see if anyone joins. Else I will start. Yeah, okay. So let's start. So hello everyone. My name is Rajan Mukherjee, and I am a TA for this course. So I am currently a research scholar at the Department of Computer Science and Engineering, IIT Kharagpur. So I'll be taking this live session for NPTEL course on programming in modern C++. So like if you have attended previous classes, you will know. So this is an interactive session. So we'll be discussing the questions regarding week 12. I will also do a little recap regarding it. So feel free to ask any questions whenever you have. I will answer them. Okay, so let's start. So we'll be discussing week 12's content. So in week 12, I will give a short recap of what was taught, and then we will go to the various model questions or assignments that you may face during your exams regarding week 12. So let's start. So the theme of the topic is first topic that was discussed today, this week 12, was about pointers. So recall previously you have dealt with only this kind of pointers called raw pointers. So what does normal pointers do? Normal pointers basically stores the address of a location. Stores address of a memory location. So suppose you write something like int a is equal to 5, and you also write int asterisk b is equal to address of operator a. So if this is a in memory, it stores 5 and its address is suppose 1000 hex, then b contains this 1000 hex. So this is called the address or the pointer. Now in C++ or like the problem with the normal pointers, even if you will face in C in this kind of formats, that whenever you do a dynamic allocation, so this is you know this is normal allocation, static allocation. Now suppose you do a dynamic allocation, int asterisk c is equals to new, int asterisk c is equals to new int, let's say 6. So that means there is a location in the memory which stores the value 6, and suppose its address is 3000 hex. So C contains this 3000, and if we want to access what is stored in C, then you will just do this asterisk C. So this is how you use a pointer normally. Now what happens in C? So since you have dynamically allocated the memory location, so it is the task of you, it is your task to delete the memory. Correct? What happens if you don't delete the memory? So that means suppose your program is running, so suppose you have written a code for let's say like let's say your normal day usage, suppose you have written a code for your Amazon sub service. Okay, so you have written a code. Now you are your suppose you are a like suppose when a customer enters his or her data, then a class object is created. Suppose a customer is trying to buy something from Amazon, so he or she has put five or six items in her cart. So for each item you are basically creating an object, right? So suppose the customer now like has done the shopping and he is leaving. Now your cart remains there. So in programming terms, I mean to say that cart doesn't remain empty, it remains full. So that is how, if suppose like one, not for one customer, like there are 1000 customers, everyone is doing those kind of things. So over the course of time, your the amount of memory that service was taking will continuously increase. Let's suppose understanding in your more simpler term, like suppose you are writing a Word, you have opened Microsoft Word, you are writing, okay. Now you know like how to check the memory in your computer. So you do this task manager type of thing, you understand, I know all of you understand how this task manager is in a computer. So you go to the task manager, you see that your Microsoft Word is suppose consuming 20 MB memory when it has been opened. Now over time, you say after using it for 30 hours or 30 minutes or 40 minutes, you again check the usage of the Microsoft Word in your task manager. So it is supposed to remain 20. Suppose it increases to 30 or 40, that means your program is leaking. It is continuously eating up your memory, the RAM. So if that kind of memory leakages happen, so over time, the whatever RAM you have in your memory, it gets exhausted. Suppose you have a 4 GB machine, if memory happens continuously, so that memory will just be useless after some time. It will all be used by your program. So that is a problem of memory leakage. So in C++, you don't have normal by if you are doing this kind of content allocation, so no auto memory like deletion or say memory management. So these pointers don't give us that automatic memory allocation and reallocation flexibility. So how that how to solve this? So C++ provided us with a feature of smart pointers. So what are smart pointers? So technically, in terms of understanding, what are smart pointers, you can consider smart pointers at some class objects, at some classes object. So what does smart pointer do? Smart pointer provides as a wrapper over your normal raw pointers. So you have your normal int asterisk p, where everything you need to do upon yourself, like every thing. Suppose you have inserted it for null right here. So every allocation, deallocation, everything you need to do yourself. Now in smart pointer, you don't have to do it yourself. Smart pointer is basically is an object which can handle this automatically. Now how does it do it? So you see, any class has its constructor and destructor, right? So when you create the object, basically your constructor gets called, and when you delete the object, your destructor get called. So the new operator and the delete operator, you can assume that those are present inside this constructor or a destructor. So whenever it goes out of scope, the destructor is there and it will delete it. Now it maintains some sanity checking. Obviously it has to do some kind of sanity checking, otherwise it will lead to an error. Suppose you are trying to suppose you have just initialized a smart pointer, and you have just declared a smart pointer and have initialized it. That means it contains null value. So when it goes out of scope, the destructor doesn't call the delete there. It checks whether it is a null pointer or not, because if you are trying to delete a null pointer, then your program will crash. So this kind of sanity checking it does. So we are introduced to two different kind of smart pointers here. So one was unique pointer, another was shared pointer. So the another was weak pointer, but we'll come to it later. What was your what flexibility does a unique pointer and shared pointer give? So when you are declaring a pointer as unique, so that object that pointer will only be, that unique pointer will only hold to only one address location. So let me explain you what do I mean by that. So suppose you have this address location and your unique pointer is pointing to it, right? Now you say another pointer tptr cannot hold to it, cannot be hold to it. Let just uh, like think it in terms of your raw pointers. Suppose you have int a star is equal to new int 6. So 6 is here and A is pointing to 6. Now you can, in the next statement you can write this, right? Int b asterisk b is equals to A. So you have written B is also pointing to this. So this was allowed in raw pointer, but in shared unique pointer, this was not. This kind of like pointing is not allowed. The reason is very simple. Why doesn't it gets allowed? So suppose in like in this case, suppose if one deletes B, and suppose you are trying to suppose one writes a statement delete B, so that means these address locations will be given back to the memory. So now suppose now you somebody wants to goes to print cout asterisk A. So basically B is now null, and similarly A is also null because both are pointing to the same location. So now somebody goes to print this, so the program will again crash. It will give a dump, memory dump. So that is wrong way of coding, right? So two pointers are pointing to the same address location and we are deleting one. So that is a wrong way of coding. So as a result, the unique pointer doesn't allow it only. So it has a very tight sanitation for because of that. So if somebody writes uptr is equal to tptr, so what happens in that case? In that case, uptr tptr is equals to uptr. Somebody writes that. So what happens in that case? In that case, tptr goes there and uptr no longer holds it. uptr at this point holds null pointer. So only one unique pointer can hold an object at a time. So this was the very hard and first rule. So if you are passing these unique pointers via to a function via parameters as a value, then what happens? The sender function loses all its the sender function no longer will be able to access that unique pointer. Only the receiver function will be able to accept it. So these are the some kind of so in that case you need to send it by not as a value, you have to set it by an reference. So these are the common mistakes that can happen while using unique pointer. Next, we are also introduced to another kind of smart pointer that is called shared pointer. So in shared pointer, this kind of referencing is allowed. More than two elements can hold, more than two pointers can hold the same object location. And how does it do it? It maintains a counter, like how many, in that case, basically there is another box, not only this memory block, there is another block which is called, maybe let's call it content. That contains a number of shared pointers holding it and number of weak pointers holding it. So whenever we do this kind of copy, so that counter gets updated +1 or -1, whether we are deleting it. When we are deleting it, it gets reduced by 1, and when we are pointing it, it gets increased by 1. So this was the concept of shared pointer. Now now shared pointer just basically helps in just reducing what unique pointers were doing, were not allowing. Now let's come to weak pointers. So weak pointers are kind of shared pointers, but they are not able to access it. So a weak pointer can point to a shared pointer, but they will not be able to access the variables. They are only used to check whether that a particular address location is currently in access, is being accessed or not, that it exists or not. So that is the reason shared pointers, like weak pointers, are used. So typically a weak pointer can be converted to shared pointer only using your log value. So that was being said in the class, and I hope you have followed the lectures for it. So that was another concept that was told in the class. So apart from these two topics, you are introduced to a third topic. So one was this pointers and raw pointers, weak pointers, shared pointers. The other part that was discussed here was your synchronized memory access. So suppose you have a this is your memory, right? So you have written a portion of code. So it has a class, and you can create multiple objects of the class. Suppose let's again consider the Amazon example. Suppose this is your a piece of code on your Amazon web, right? So a customer comes, and suppose that is basically an object of this class. A customer is basically an object of this class. Okay. So he or she performs his or her like marketing. Now your program should not be only be allowed at a time to be accessed by one customer. You need multiple customers to access this your program, like, or your Amazon program, like Amazon service, right? Obviously, and all of them will be uh, in your, like, accessing at the same time. So let's suppose you have a 10 biscuits packets on sale in Amazon, but there are 20 people accessing that Amazon service to buy that biscuit. Obviously there are 10 available and 20 people are there. So everyone will not get the biscuits, right? So how to do this? In that case, there will be a race condition, like not a race condition. Let's discuss race condition, but it will rise to a problem, right? Everyone is not going to get them, and you need to update one by one. So here comes the concept of this synchronized memory access or threading. So what is a thread? So will have heard this term thread, normal computer specification. So you will, the CPU vendors will say, this CPU supports 10,000 threads. This CPU supports 20,000 threads. So CPUs are basically a copy of your program in execution. So you have written a code and you are running that code. Okay, so when you like compile a code, it produces a dot out file or dot o file, object file, and then you run that file, right? So a thread is basically a program in execution, but each thread of a program basically has its own address space, has its own memory space, so that they can not, those two threads do not cause conflict or conflict of resources inside it. So let me give you a better example. So suppose you have written this code, int is equal to 10. Suppose int b is equal to 20, or int c. Okay, int c. So int c, int d. Okay. Suppose you give, the program will take c as an input, and d will be a plus b minus c. So this c will be basically an input from your user. Now let's say there are 4 different users. Now the traditional way of programming or thinking, what you have already thought about, will basically user 1 will first execute its code, it gets executed, and then user 2 will execute it. So this kind of thinking is called like synchronous way of doing it. Then u3, then u4, right? So for one, not all of them, only one at a time can access the code and run it. Now thread gives us the power of asynchronicity, where all of them u1, u2, u3 and u4 can call this program at a time. They don't have to wait for one another. Here what was happening, first u1 was executing the code, then u2, then u3, and u4. Now it is not. When you are using a thread, so this will be in one thread, this will be one separate thread, this will be in another separate thread, and this will be another separate thread. This C is something which depends on these users. Now because now see, this C depends on its user, so it has to have a though so the so we need to make a solution such that this doesn't get a like haphazard way of getting input to the C. So we need to make sure only one when one is updating the value of C, no one else is updating the value of C. So this requires this memory access synchronization. So that means we need to put some methodology here such that only one at a time can access this code. That means each thread wants exclusively to access C. Correct. So what C++ provide us is this term called mutex. So we will lock this one using a mutex lock, and when this function input is done, then at that time we will use a mutex unlock. So even though we are giving the users to access the code asynchronously, the C part, which is common and it is dependent on the user, they had to use it in a synchronous way so that no conflict appears. So this is the reason mutex are used. So if we go to the module once, so if you are looking at this module, you will see this code which was basically doing this. So we are allowing to 20 threads to do the work in a faster way. Now for mutual exclusivity we will be using mutex. So this is what is mutex. Correct. So this is how we use mutex, and you need to use this lock and unlock facility.
Hello.
Hello.
हेलो सर.
Hello.
सर एक डाउट था मुझे.
Regarding
सर मुझे वीक 8 में सर ने जो फंक्टर्स के बारे में पढ़ाया था वो समझ नहीं आया है. एक बार बता दो कि व्हाट इज फंक्टर्स.
So I am now discussing week 12. So if you want like I will discuss.
सर प्लीज डिस्कस इट नाउ.
So
क्योंकि मुझे आगे का भी पढ़ना है.
so I cannot do it, right? First I need to complete this. At least let me complete this week 12's what I am discussing now. Then I have to discuss the solve problems regarding this week.
Sir,
So,
please take my doubt now so that I can
wait for 5
study.
minutes. I need to complete this week 12 module. Then I am coming to you.
How much time it will take?
It will take more 5 minutes.
Okay. then please take my doubt.
Okay, so this is how you are using those mutex thing to do the to for this shared variable uh, accumulate. Right. Another so this week another more ways of doing this concurrency and synchronous way of accessing a code uh, that might require mutual exclusivity was done using mutex. Other was their atomic, another way of doing it. Other than that, uh, all are kind of same. Okay, so another concept was of deadlock. So what happens in deadlock is, suppose both A and B are trying to access that at the same time, and both have, so suppose you have put two locks inside it, one lock and two locks, and there is some piece of code and there is another unlock and unlock. So what may happen is there is a piece of code which may depend on the first lock, and this piece of code is now not able to access that lock. So that will create a deadlock. So it will be stuck in that part of the code, and it will not be able to uh, access get out of it, because one is dependent on another. So that causes a deadlock. So these were your topic of week 12. Uh, Now we will discuss the questions for model questions for week 12. So before that, let me see what his problem is. Functor.
So can you now
Okay,
take my doubt?
deadlock again to us. Okay, so I will come back to deadlock once.
Hello?
Okay, functor. Okay, give me 1 minute.
Sir, what is functors? Explain in detail, please.
So functor is nothing. So the you have a function, right?
फंक्शन पॉइंटर तो समझ में आता है मगर फंक्टर्स क्या होते हैं वो
Functor
नहीं समझ
is
में आता.
basically you have written this struct. Suppose let's say distance. Okay. Suppose you have,
स्ट्रक्चर है सर ये.
huh?
दिस इज अ स्ट्रक्चर. दिस इज अ
Arey, let
स्ट्रक्चर.
me complete now. Then you will ask
ओके
yourself.
ओके.
Arey, just wait little bit. Int a b. So suppose now you have this operator int operator this, and suppose it takes in suppose x, and now you return return a star b star x. So now you see you have this operator you know that operator keyword that we use for doing overloading. So basically you are overloading this colon. So
कैन बी डिफाइन.
when you are doing a
सर
distance like this,
दिस इज अ सर दिस इज अ ऑपरेटर फंक्शन.
operator, yes, operator function.
Sir, operator function we also have in typecasting. Like
Yeah,
for every
yeah.
typecasting we have
So
operator
so
function called
so
internally.
so what is the problem?
So sir, that concept and that
These are
sir
different.
that operator function is used in that context,
Yes,
typecasting context.
yes.
So
This is
this
a functor.
same operator
Yeah,
function is used here.
yeah. That is not a issue. So any
So sir,
structure
what is
which
the
has this
difference between
operator
both?
function, that is a functor. Huh?
सर ऑपरेटर फंक्शन जो टाइपकास्टिंग में यूज हो रहा था वो टाइपकास्टिंग के लिए था. तो वो टाइपकास्टिंग वाला यहाँ पे क्यों यूज हो रहा है फंक्टर्स.
You can use it. Like this is operator overloading. You can do it.
सर ये ऑपरेटर फंक्शन जो है इसके बाहर हमने ब्रैकेट दोबारा से एक और ब्रैकेट लगाया है जिसके अंदर इंट एक्स लिखा है. तो इसका मतलब क्या हुआ ये एक्चुअली में फंक्शन है या फंक्शन
This
दो
is
दो
called
ब्रैकेट
functor.
सिंबल क्यों लगे.
This is called functor. So basically, when you have to call the functor, you will do this distance and suppose you pass 10, so this 10 is this x.
तो सर जो फंक्टर होते हैं वो किसी क्लास या किसी स्ट्रक्चर के अंदर उनका प्रेजेंट होना जरूरी है।
Yes, so you will have a class and you have this.
तो
You,
सर ये जो ऑपरेटर फंक्शन है यही फंक्टर होता है
yes,
और इनका किसी स्ट्रक्चर और क्लास के अंदर प्रेजेंट होना जरूरी है।
yeah, you need to have it inside a class or a structure for functor.
ओके, एंड दैट फंक्टर शुड बी प्राइवेट और पब्लिक इफ इट इज इन अ क्लास।
You need to be public, obviously, otherwise you cannot be able to handle it.
सर ये जो हमने डेफिनेशन लिखी है डिस्टेंस ब्रैकेट 10,
Hmm.
ये तो अगर ये डेफिनेशन क्लास की डेफिनेशन होती है
Mm-hmm.
तो क्लास तो इस तरीके से तो क्लास का कंस्ट्रक्टर कॉल होता है, तो कंपाइलर एम्बिग्यूटी में नहीं फंस जाएगा कि वो कंस्ट्रक्टर कॉल कर रहा है या ऑपरेटर फंक्शन कॉल कर रहा है।
No.
क्यों सर? अगर ये क्लास होती है डिस्टेंस और
Yeah,
डिस्टेंस ब्रैकेट 10 कर दे तो
the thing is in that case, so the concept of constructor and destructor is okay. So it will not happen in that case. The one of the reason is,
सर दोनों को डिफरेंशिएट कैसे कर पाएगा कंपाइलर कि ये जो कॉल है
Mhm.
ये कंस्ट्रक्टर की कॉल है या फिर ऑपरेटर फंक्शन की कॉल है, इसको रिजॉल्व कैसे करेंगे? क्योंकि सर क्लास का नाम ब्रैकेट करके कुछ भी हम देते हैं तो corresponding parameterize या default constructor कॉल होता है।
Yeah, but think about it. When does a class does that? When you are defining a new class, you are creating an object of a class.
Yes,
But
here
here we are not doing that.
sir, here we are not here we are not here also we are creating an object like
No,
we
so
we
so
are
so so
writing class name, sir, we are creating unnamed object, a object which has no name, but
so
call to constructor will
so
happen.
so 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 wait. So right, like you are doing this. So there are lots of animations that define it. Okay, so you are doing this. Suppose you have a like you are doing this. Now see, this is also has a return type. A constructor doesn't have a return type. So these are the things that will make it not ambiguous to the compiler. These kind of things.
तो सर ये जो मैं बोल रहा हूँ सर ये जो आपने ये स्टेटमेंट लिखी है डिस्टेंस ब्रैकेट 10,
Hmm.
ये स्टेटमेंट तो कंस्ट्रक्टर को भी तो कॉल कर सकती है ना।
And it will not be able to call, because in that case it will see that when as a constructor is called, when you are creating a new object. In this case you are not creating a new object, you are calling this is the reason it is called functor.
नहीं सर, हम इसको तो कॉल कर रहे हैं सर, जैसे हम
We are not
अगर
creating a structure object.
नो सर, अगर ये डिस्टेंस अगर एक क्लास होती, अगर ये कोई क्लास होती, स्ट्रक्चर की जगह ये डिस्टेंस कोई क्लास होती और ये स्टेटमेंट हम लिखते डिस्टेंस ब्रैकेट 10, तो उस केस में ऑब्जेक्ट कॉल होता ना,
So you write
कंस्ट्रक्टर
a
कॉल
code,
होता।
and so instead of asking me, you write a code and check it is happening or not. That is a easier way of doing it, right?
तो सर जो फंक्शंस होते हैं उनके लिए ऑपरेटर फंक्शन इस तरीके से डिफाइन करना जरूरी होता है।
Yes, that is the only way of doing it.
तो यही फंक्शंस होते हैं।
Yes,
तो सर फंक्शन पॉइंटर्स और इनमें डिफरेंस क्या
there is
होता
no
है?
difference.
फंक्शन पॉइंटर्स आर दे आर एनोनिमस,
Yes,
वो
they are same. Yes,
सिनोनिम्स।
yes. So
तो सर
you can.
why we use function pointer, why we have a concept of function pointer, function pointer if we have function pointers?
You see, these are the questions that C++ people have defined. Okay, so all of them's function are same. Okay, function pointer, functor, the function references, those are all works are same. They have just defined it. I don't know why they have defined it.
तो सर फंक्शन पॉइंटर और पॉइंटर में तो कुछ ना कुछ तो डिफरेंस होना चाहिए। अगर एक चीज सारी चीज सेम है तो मल्टीपल चीज डिफाइन करने का फायदा क्या है?
I don't know.
ओके, तो सर ये जो ऑपरेटर फंक्शन है इसका सिंटैक्स यही होता है हमेशा
Yes.
कि ऑपरेटर ब्रैकेट और ब्रैकेट के अंदर नंबर ऑफ पैरामीटर
Yes.
एनी टाइप। अगर सर अगर एक से ज्यादा पैरामीटर्स होते हैं ऑपरेटर फंक्शन में तो कैसे कॉल करते हैं?
You can write it. It is it is just like function. There is nothing difference.
एंड सर अगर ऑपरेटर फंक्शन में अपकास्टिंग वगैरह होती है, अपकास्टिंग, इम्प्लिसिट टाइप कास्टिंग, जैसे अगर यहाँ पे हम डिस्टेंस में इंटीजर वैल्यू एक्सपेक्ट कर रहा है ऑपरेटर फंक्शन, यहाँ पे हम डबल वैल्यू पास कर रहे
Yeah,
हैं,
yeah.
तो डबल
Those
टू
things
इंटीजर कर
those things are not issue.
सर होता है वो।
Anything that happens with function is all is done here.
एंड सर ऑपरेटर फंक्शन में हम पैरामीटर कोई क्लास ऑब्जेक्ट या स्ट्रक्चर ऑब्जेक्ट डिफाइन कर सकते हैं।
Yeah, yeah. Anything.
जैसे ऑपरेटर फंक्शन के अंदर हमारे पास बेस क्लास का पॉइंटर है एंड
You can do
ऑपरेटर
anything what you do with function. There is no difference.
एनीथिंग वी कैन डू विद फंक्शंस वेयर
Yes.
वी आर कॉन्स्ट्रक्टर।
Okay. So
So
let
sir,
me.
what is the use of this? What are the applications of function?
So you know sort function, right? What happens in a sort function? You need to give a comparator.
Sir, sort function, q sort function, like uh, it is a function pointers are used there.
Yeah. So
Not
you can give a functor also. No, that is not an issue.
sir, how can we get a functor? We have to define a structure or a class separately, and then
What?
sir, for in q sort function, if we use functors,
Yeah, you
then
can use functor.
we have to put compare function in separate class or a structure,
Yeah.
and then call it.
Yeah. Nothing more.
Means operator function we have to put in separate class,
Yeah.
and then operator function is called.
Yeah.
Okay.
Okay. So
And
let's.
sir, what one question more, sir? Little bit, sir. Can I ask?
So come at 8. Let me complete this. This I have to complete
Sir, one
today.
question, sir.
So
One
come at
question.
8. I will be there. Come at 8. I will be there.
Sir, it will not take less more than a minute, sir. One
Oh,
question. Straightforward, rapid fire question. Sir,
what?
one question, sir. Only. Sir, the question is that, sir, for every when we do typecasting, then internally operator function is called. Like we do implicit typecasting, then internally operator function is called for
Yeah.
doing that typecasting.
Yeah. For that typecasting, you need to do that.
So what kind of typecasting we do, operator function will be called.
Yeah.
Whether it is C style casting or C++ typecasting.
No, C++ typecasting, you need to define those kind of casting parameters.
Like in static cast operator,
Yeah.
we define in a class operator function.
Yeah.
So that operator function we overload or write a fresh one.
You need to overload.
So much means every typecasting internally operator function is called.
Yeah.
And what is the header file in which it is present?
I don't know. You need to like a IO stream or a stream, those kind of things that can be.
Okay. Thank you.
Hmm. Okay, deadlock. So let me go to the deadlock slide one more. So you have this kind of code. Yeah, so you have this code like of there are two variables int1 int2, and you are trying to uh, access both s1 and sh2 here. Now the problem is, let me so these are basically operating system kinds of problem, but let me be define you like this. So you have two users, user 1 and user 2. Okay, now user 1 has acquired lock 1 and user 2 has acquired lock 2. Now the problem is, if one has a lock 1, another has a lock 2, now none of them will be able to change s1 sh1 or sh2, because to access sh1 and sh2 they need to acquire both the locks. So this will lead to a deadlock. In the sense, both of them are waiting that other one will relieve sh1 lock or sh2 lock, but both are still waiting because because one is expecting sh1 lock, another is expecting a sh2 lock. So it becomes a very circular problem. So if I let me clear my frame and share the start of it. So suppose you have your user P1 and P2, and it has acquired lock sh1, and it has acquired lock sh2. But to access this suppose shared resource, it require both sh1 and sh2. Now P1 is waiting when sh2 will get released. Similarly, P2 is waiting when sh1 will get released. So this basically is your deadlock, because both are waiting and waiting, but but none of them are giving up the resource. This is what is called deadlock. Okay. Now deadlock, how to like get rid of deadlock. There are many theories in life that how to make rid of deadlock. So one is that if this continues for like in what happened in OS, I'm saying. So in OS is basically written, suppose you are running a Linux code or something, or because C, C++ also, those are basically written in C programs, these Windows codes and all. So one of the things that they do in that case is that one trivial way of doing it is that if this thing exists when none of them are able to access this code, then they make sure that both of them releases both the lock, and only one at a time can acquire it. So that is how like trivial way of handling it. Okay, so that is deadlock. That is your resource management. So I will say that when if any one of you do this course on OS or computer networks, or even database, so in these courses have lots of like this kind of deadlock, semaphore kind of things, this threading, these deals with that. So if you ever take up this course in your college or in suppose NPTEL, you will come to know more about this deadlock, shared resource management, and everything. So let's come to the problems of this week. Can you suggest any good textbook on smart pointer? I will suggest you the slides that sir has given. You see there are many sorts of resources source. So if you go to any beginning of the slide on, if you are wanting shared pointer, right? So see here sir has mentioned lots of sources. You go to these sources and try to find out what it is written. You will get a very nice overview, like these Scott Meyer training courses. These are free courses. You go there, you see, you will find a very good examples. The C++ multi-threading, these pointer, these are the very, in every slides I will suggest, every slides you, all the modules you go, every slides beginning there are lots of sources given. You can go there and check out for details. Okay, so let's do this. So here you have, a structure. You have a functor. The functor, and Here is your constructor, and here is your print function. Now you are creating a thread to handle this. So let me give you another example of a thread. What happens when this statement gets called? Suppose this is your program P1 that is on currently running. When you create a thread like this, what happens? It gets a parallel similar copy of your program P2, and this thread then executes whatever you have written inside this. This is how threading happens. So these big applications like I don't know how in Windows it is shown part of the thread that is running, but every big applications like if you are running a game or something, those basically runs on threads, because one thread will not be able to like accelerate or access all of the code. It requires different parts of program, so they run all the threads parallelly. So what happens here? So question is, what has to be passed here such that the output becomes 0006,000. So basically we need to call the product. So if you have seen the answers, so basically we need to call the product and pass IL as a reference, or and as a pointer this. So which of them does this? So option 1, this is wrong, because we are passing address of IL, but it is expecting a reference of IL. Okay, so this one will not happen. Option 2, IL res, this one will correct, because this will pass a reference and this will pass an address. Next is stdref IL res. So this passes a reference, or let's say R value. So this also correct. This one, you see only one thread is running. You don't need an std bind for this case. So this one is not required. So option B and C are correct. So what will happen when it goes there? Basically, we are passing a reference of IL and this result here. And this in this T join we are waiting what? So this P2 does complete this execution of this product, execution of this, P2 completes execution of this, and then when it is over, then this T join will execute rest of the code. So basically, once this happens, it once it gets like out from P1, P2 gets executes its part, then it's rejoin this main program. This is why it is called joining. This is creation of thread, and this is joining of thread. So any doubt regarding this, you can ask. Okay, so let's go to the next one. So suppose you have been given this code. This is a print function and this is your main function. So you are using an std bind. So what does std bind do? Bind basically makes sure that print uses these values. So what is cref? C is basically constant ref. So we saw ref previously, that was passing a reference. Std ref, cref basically passed a constant reference. So, and what are these? Are underscore 2 and underscore 1. So what are these underscore 2 and underscore 1? These are called placeholders. Now the tricky part of this placeholders is we are saying does this prints first, this one will be the second element and this one will be the first element. So whenever I call print, or let's say whenever I call this f, so whatever the first element, whatever the second element is, that goes here. Whatever the first element is, that goes here. Right? This is what it means. So let's consider its terms of n1, n2, n3 and n4. So n1 becomes n1 becomes 20. n2 is already val. What is val? 10. n3 becomes 100 and n4 becomes same val, reference of val, that is 10 or minus 10, whatever you take. So let's say minus 10. Okay, so what we are computing here, this 20 minus into is minus 10 plus 100 in 3 and in 3 is 10 because we have already passed it as constant, it will not change. So this becomes 10 10 cancel, it becomes minus 80. So correct answer is B. Okay, so in this case the main confusing part is this placeholder. So when you give this as placeholders, so that means the value of n2 will come, n1 will come from this second thing in this function of bind. This one will come from the first value that is being inputted, that is 100. Right? Val has already been given, that is minus 10, and since this is a constant reference, we have already given its value as 10. So 10 minus 10 plus 10, 10, 0. This one is 100 and this one is 20. That is 20 minus 100, that becomes minus 80. It will be same kind of. It is kind of same. At least as per I know. They don't give nothing different. So it will be those kind of MCQs, this kind of output problems, those kind of things. please question 2 once again. Okay, I will discuss. Will be similar to past year papers too. Maybe, I don't know. If assignments are kind of from the past years, so maybe. That I don't know. So whatever, so I am in TA for the first time. So whatever I know is that this kind of questions only comes in the like final exam. I don't know. I don't have the question paper for the final exam. But I guess completing the code will come. See, suppose in your MCQs also there are many completing the code kind of things, right? Like this first question which we solved. These was also kind of same that gets is given to you for completing code kind of thing. It is not different. Okay, let's. Okay, so this has a problem, so I will discuss it again. So, in this question, you were asked what will be the output. Okay, so there are two things you need to place here. One is this placeholder, another is this bind. What does bind do? Binds basically you can think it as a function, functor, those kind of things. So basically, it will bind you to this to this bind f to this print to these values outside after date. So whatever is the state of these values anywhere when it is being executed, this f is being executed, that kind's value will be considered. Fine. Now let's understand what is this. So basically f is print 2 underscore 2 val underscore 1 cref val. Cref is basically constant ref. So this value will remain constant, that is 10, whatever it be. Now these placeholders are numbers. This means it will accept value from placeholder 2 and this will accept value from placeholder 1. So in this case we are passing f 100 20 minus 100. So what is there in placeholder 1? 100. So we will be passing 100 here. What is there in placeholder 2? 20. So we will be passing 20 here. Now let's reflect it in N1, N2, N3, N4. Ignore this. This is not required. Nothing is there for placeholder 3. So this has constant reference 10. Val value has become minus 10. So it will be minus 10. Now calculate this. N1 minus N2 plus N3 plus N4, it becomes 20 minus 10 plus 100 plus 10 minus 10 cancelled, that will become 20 minus 100, it is basically 80 minus 80. Yeah, N2 should be 10 and N4 should be minus 10 because N4 has been declared as that constant drift, so its value is not changing. And N2's value has been changed, N2's value, that is based on val, see, it has already been changed. Okay. So why use std when we are using namespace std? Oh, this is the concept of that std inside, that nested std. You remember nested nested namespace? Placeholder is a namespace inside study. Mm-hmm. Then, oh, nested namespace. Okay. Yeah, yeah, sure. Is there anything I can delete here? So nested namespace is basically you have a namespace, suppose P4, and you can inside it there is a namespace P3. This is basically namespace. So what are the specific sources or question banks from our assignments are being delivered? I don't prepare assignments. Don't ask me this kind of questions. You have solved 12 assignments. Why are you tensed now? You should be able to solve those questions. What I know is they prepare themselves. I know that they prepare themselves only. They don't take some question bank or something. Yeah, so this is something was nested namespace means. So you have a namespace, suppose P4, and inside is there is P3. So if you have to access something inside this, so you need to use P3 colon colon. Suppose you have something here. Uh, so suppose P4 and you need to access P3, so you need to paste P4 colon colon P3. Those kind of thing. That is nested namespace. I don't remember the module in which nested namespace was declared, but taught. I could have reference to it, but you can find that. This is not any big topic. Okay. So let's come to this one. Question is, what is the output? So what is happening here? So basically you are creating three threads and you are calling this function step up with specific values of steps 1, 2 and 3. Now you are using a lock, or let's say mutex. So mutex is here to for this part of the code. So what it is trying to do, why it is applying a lock here? Is the lock necessary? How do you find the value of n1? I said na placeholder. So see, this is number 2 placeholder. What is there in number 2? 20. This is placeholder number 1. What is there in number 1? 100. That is how we find value of n1 and 2. Understood? Simple concept is check the placeholder number, correlate with the when f is being called. Whatever there is number 2, it will go there number 2. What is there in number 1, it will go there number 1. Forget the order in of that parameter passing what you learned in function. This is different. Placeholder concept. Okay, so here we are using threads T1, T2 and T3 to access this part of the code. We are using a lock. So why we are using a lock? You see this val part that is global will be shared while this step function is being done only by once. This global value val will be shared by all. So suppose this thing may arrive. So this is T1, T2 and T3. Val value is first one. Suppose in parallel if what happens, so T1 comes, 1 plus 1 is equals to 2, 1 plus 2 is equals to 3, 1 plus 3 is equals to 4, right? So what will happen if we allow all these 3 without any lock to run in parallel, so the final value can be anything between 2, 3 and 4, right? Or it can be more kind of thing. Suppose T1 and T2 has updated it, then T1 has updated, T2 has updated it, then we are running uh, at that moment we are running T2. So in that case it becomes 3 plus 1 4, whereas this value does not get updated in between. This is the last value that is being computed last, right? So this is the problem. So if you run all of them in parallel, this value part, which is the critical part of the code, is being done asynchronously. If it happens, the value can be updated into any value upon completion. So as a result, lock is being used on this val mutex. So because of this lock, only one thread will be able to access this part of the code, one at a time. So as a result, what will happen? As a result, this value will be updated only once. So it will be updated 1 plus 2. After suppose T1 gets completed, then only T3, T2 gets access. It will update it to 1 plus this value plus 2. Then T3 gets hold. Then it will update it this value as plus 3. So it becomes 7. Now, if there was no lock, we don't know what would have happened. It could have given any number values, range of values. So that is the problem. Any doubt regarding this question? Okay, so let's go to the next one. So what will be the value here, like output here? See, same kind of question. You have a mutex, you have lock unlock, there is a slight difference that makes this thing different. So you have a global value, global val, and you have a thread local val. So whatever this does, this part, this code does update, and whatever this val is, the operation happens inside thread local val. So you need to consider it in this way. So this is your main thread. You have a thread local val equals to 1, and now you are doing a value. So here in main thread value is equals to 0. Correct? Now you are creating 3 threads, T1, T2, T3. Now since it's a thread local val, so these vals that are updated here will be local to these threads. It will not affect this main thread val. So as a result, the output in this case after this join operations will be 0. Because here we have not used a global val, we have used a thread local val. The thread local val output, that is the update that happens, it remains localized inside that variable only. So any doubt regarding these two? These are like peak. These are your peak assignments for understanding threads and synchronization. Okay, so let's go to the next one. This is another such classic example of if you are not able to view this, let me share it with you. You can access it here. Okay, so this is another of your classic, like if you have done a course on OS or something, you will know this. So you have a printer and a scanner. Basically I mean to say you have a single machine only which can do a print and which can do a scan. But if you have operated a printer or scanner, they can do only one at a time job, right? It cannot print multiple requests. So if you have a shared network where a printer is connected to 10, suppose 10 different computers, it cannot print 10 requests at a time. It has to solve only one request at a time. So this is what we call like job scheduling kind of problem. So here you have a main function, you have a structure, printer and scanner, which takes count of number of jobs it has done, it will do. It has a mutex. Now these are the objects that are getting created. Now this is a request copy function, and this is a request copy to function. So this is one kind of request. This thread, this is your main thread. Now it gets divided into two, T1 and T2. So T1 is requesting, is calling request one, that is this, and T2 is calling this. And they are using two different locks, one for printer mutex, another for scanner mutex. So the question in this is I have not written. So the question is what will be the output. So after both operations are done, there is a join. Question is what will be the output. First of all, see there are two std out statements, right? So basically there will be two lines of output. So uh, in one T1 has 10 as given as input and T2 has given 20 as input. So mm, so the logs are basically to update this is actually in a correct order, not in some different order. So suppose T1 gets executed first and then T2 gets executed. Let's consider this situation. Then what will happen? So then it will get updated 10, 10, and then 30, 30, right? Another case it will happen that T2 acquires the logs first, so it becomes 20, 20, and then 30, 30, right? These are the only two solutions. So since there are log, either T1 will acquire the logs first or T2 will acquire the logs first. So these are the only two outputs that are possible. 10, 30, 20, 30. And this can result in dead dog. Don't worry. The they need to acquire both the logs at the same time. Otherwise, this can lead to a deadlock. Yeah. So let's go to the next one then. So here you have a vector. You are adding two variables to the vector. . and now you are calling add to wake through T1, right? So this is a thread, so this is your main thread, and you're creating another thread to use this add to wake. What it is doing there, it is pushing two more variables, right? Now you are then printing all the elements. The question is, what will be the output of this? What cannot be the valid output of this? So this statement, what does this push? This pushes 1 and 2 to it. Then it creates a thread to call this, right? What it does, it pushes two more elements, 3 and 4, and then it prints it. Now notice a crucial point of this code, that the T1.join happens here. So why I am telling it's a crucial part of the code? Because when this part of the code is being executed, both T1 and T2 are executing at the same time, and there is no lock. So if T1, while suppose T2 is trying to execute this part of the code, this T1 thread, the main thread can print this one. So it can print 1 and 2, and at the moment suppose 3 and 4 has not been added by this thread, because threads operate in their own area, space, whatever you can call, time. And when and if it's have already executed this, then it's fine, it will print 3 4. So these and 3 1 2 and 2 4 1 2 and 1 2 3 4 are valid. These are valid output. These are not valid, because you see this pushback happens in a synchronized way. First 3 will get updated, then 4. So these are non-valid. So these are the wrong answers. So 1 and 2 and 1 2 3 4 are the correct. So I am explaining it again, why, what is happening here. Okay, let me explain it again. So you have your main thread, this is your main thread, and this is your another thread T1, which is basically executing this part of the code, right? Now what is the issue? The issue is this join statement. Join statement is one that is executed when this working of this thread is complete and it joins back. Now the issue is this join statement is after this print statement. So we don't know when we are executing it whether VC has been updated or not. It can be one of the both cases. Either it has been updated or it has not been updated. So the value of this print statement will depend whether VC has been updated by the thread or it has not been updated by the thread. So If it has been updated by the thread, it will print 1 2 3 4. It has not been updated by the thread, it will print 1 2. So 1 2 and 1 2 3 4 are the valid outputs, and 1 3 2 4 and 3 4 1 2 are the non-valid outputs. Fine, that is the solution. Any doubt regarding this? Okay, so let's go to the next one. So suppose you have been given this code. So you need to identify which one of the following is the correct thing here. So what is this returning? Line 1 returning. Line 1 returns the value stored in the raw pointer asterisk underscore point b, right? Right. So now, which of these actually return that value? So if you look at this is for this statement. So when you write suppose p colon a, this is for that. So this is not what we want. We want something in this. When we do this, this is for copy. So these two are not a correct answer. So the answer lies between this and this. Now which one to choose? Any idea which one to choose? Come on, you can answer this one. This one is very easy. From A and B, which one to choose? So you will choose basically this one because you don't want to pass a uh, so so here you want to pass the value, not the reference, and reference, not the value. Reason is simple, so that something gets updated there, it can get easily updated for so that you don't have to need that copy part thing, right? So if you send a value, you pass, you basically perform a copy, instead pass reference. That is the reason. Okay, any doubt regarding this? So this is your basically what I am saying, your smart pointer is basically an object of a class. These are definition of how smart pointers look inside your class. Okay, so let's look at the next one. So here you have a piece of code for main function, and this is your some function which updates the share pointer. It is written like that. So question is, what will be the output? So first you are creating a shared pointer SPA called 10, and then you are creating another shared pointer SPB, which is basically you are creating SPA is equal to new int 10. This you are doing. Then you are doing SPB equal to SPA. This statement does that. So the value here will be RC equals to SPA dot use count to write, because both SPA and SPB are holding on to this int 10. Let's say both SPA and SPB are holding on to it. So the first answer will be RC equals to 2. Next, we come to this. Now one thing happens in this time. This SPB goes out of scope here. So what will happen? RC count will come down to 1, right? Now we are doing SPC is equal to SPA. Now SPA C is coming. So the RC count again becomes 2. Now we are printing it. So RC is equals to 2. Right. Next we have this statement. Update PTR SPA, share pointer SPA. So we go here. Note what we pass here. We pass a reference, not a copy. If it was a copy, we have to again update it. But we are passing a reference. What we are doing here, we are updating it here again. We are creating a copy again here. So it becomes what? Another copy, so it becomes 3, right? So it becomes 3, right? So it will print here 3. RC equals to 3. Then we come out of here. So again this LP1 gone, so it comes back to 2. Next we print again. So we'll print RC equals to 2. Then we come here. We do a reset. What is reset? It deletes all the previous elements this shared pointer was referring to. So it deletes all, and it makes sure only one element is present, that is 20. Now SP count will be 1. So the correct answer is 22321. 22321 D. So this understanding this research is important. You see, we are doing SPC research, but the printing we are doing in SPA. Why? Because while after this statement, after this printout, it had only SPA and SPC. What this statement does is SPC, it means SPC and this point to 10. SPC will point to a new location called 20, and so if we print spc.useCount, it will give you also 1, but if we print the value, it will give 20, whereas if we print the value of a, it will get 10. So reset just makes sure that SPC points to a different address location altogether. That is how reset works. Any doubt regarding this? Okay, let's come to the next one. So here you have an update pointer, like those kind, another update share pointer, and this is your main function. The question is, what will be the output? So here sp1 we make a shared pointer. Let's just work it out. It's pointing to sp1. Then we do sp2 is equals to sp1. So you make sure sp2 is also pointing to this. Then we create two weak pointers, wp1 and wp2. So it is just observing this. Now we are telling that we are updating shared pointer sp1 and sp2. Okay, both sp1 and sp2 will now look out where. So here you have, you are updating sp1 and sp2. So sp1 will now point to 3 and sp2 will now point to 4, right? This part gone. Now we are saying auto p wp1 lock. So what happens here? It makes the shared pointer weak pointer to a shared pointer if it exists. Right. So what will be printed here? Will it print the value at p in this case, or will it print wp1 has expired? And similar thing update is done here, where you are updating sp2 and sp1, and you are checking on wp2 whether wp2 is still present or not. So in this case, the output will be both will be expired, because in this case you see both of them, both of the time they are one, they are pointing to initially one. Now one doesn't exist. One has already been over here in this case. So both of them will be basically expired. W1 and WP2 both are expired, right? Because both of them values are not valid anymore, because both of them are pointing to one, and now one is no longer in the memory because after those resets. Any doubt regarding this? Okay, so let's come to this one. So here you have basically you need to, so basically this code, this was part of your assignment. Basically this code you need to write the syntax for smart PTR, right? So you need to write your own copy constructor, you need to write the dereferencing part, and you need to write the indirection part. So dereferencing we already saw how we do it. It is t ampersand operator asterisk this const, and similarly your indirection part will also be this. So in that case you send the address, so in that case it will be operator this const. Now the copy constructor is your like similar copy constructor, smart PTR another smart PTR that you are expecting, and then you will update it this pointy to this smart PTR and that. So this is very doable. I feel this everybody can do it, because syntax of this kind of things we have already done a lot. Okay, so let's go to the next one. So you have been given a class list here. It has some public functions like add, by traverse, and this is your default constructor. It has its private members, basically first and last. So this is your node variable. The node variable has two nodes, next and link. So if you have if you know linked list, so it basically it's like this. So this is your node, this is your info, this is your previous, and this is your next. And the dlist, so the dlist is basically consists of most such nodes, has two pointers. One is the first, and another is the last. The last end pointer, end and beginning, it has both. And then we have to do write a code for bit traversal. This is what this question wants. So how will you do it? So if you know linked list, so the first one, you need to write a bit traversal for first to last, and for the second one you need to do a bit traversal from last to first. So you see one more thing is the first, next is your uh, so in each node next is your first is your shared pointer, but the previous is your weak pointer, so you need to update that accordingly. So in this case it will be shared for this line 1 pointer node t is equal to first, t not equal to null, t equal to t next. So there goes your front like first to last traversal. For this part you need to use a weak pointer because it has a weak pointer, so from last to first. Shared, so no, weak ptr node t is equal to last auto p is equals to t dot lock to convert it into your shared pointer, and then p is equals to t is equals to p next, p prev, that will do it. So that will give you a traversal from last to first and first to last. So any doubt regarding this? So why do you convert the weak pointer into shared pointer in the single loop? Your shared pointer, weak pointer cannot access anything. It just observes. So if you noticed this question which I did, so basically it is used for this kind of purposes to notice whether that uh, uh, thing is being uh, actually being there or not. So one in this case is not present anymore. So for this kind of observation purpose, shared pointer, weak pointer is used. So when we use the lock, it basically converts it into shared pointer. So without converting into shared pointer, you cannot be able to access it. So that's the reason to access the element here, we need to convert it into a shared pointer using lock. Okay, so let's go to the next one. So this one is your question on mutex. Okay, ignore this part. I have written it in the next question. So basically, here is your sender function and receiver function. Receiver and sender function. It doing some stuff. Here is your thread. It takes your account number and it's updates or sender or receiver kind of function it does, and this is your show balance function, and it doesn't end until you press the join, and this is your algorithm for sender or receiver. This part of the code there is nothing much to understand. You need to understand here how to make sure, because in your banking system the bank balance is same. Suppose you have your bank and it has 1,000 rupees. Suppose depositor 1 takes out 100 rupees and depositor 2 takes out 50 rupees. So you need to synchronize it. Suppose if 50, this withdrawal of 50 happens while this is happening, so in that case incorrect value should get recorded. So you need to do it synchronously, otherwise, so correct value after withdrawal will be how much? 850. But if you are doing incorrectly, it can come either 900 or 950 if you are not doing it synchronously. So for correct like execution, you need to use the locks. So you will declare a mutex, AC mutex, then AC mutex dot lock here, AC mutex dot unlock here. Similarly, you will use a lock here and you will use a unlock here. That is the concept, nothing more. To maintain that only one person be able to update the bank balance at a time. Okay. So that was the last question for this course. Thank you for joining. So this was the last class. Yeah. If you have any doubt, you can ask. Question 11 once again. Okay. Fine. So you have a list. So this is your node. So this is a node of description. So this is your info. This is your previous. This points to your previous node. So if this is your node, it points to this node's address, and this next points to your next node's address. So this is basically called a doubly linked list. So this linked list is stored in this. So it has say two pointers, first and last. So first points to the first node in the list, it points to this, and the last points to the last node in the list. Suppose there are more nodes here. So this is what last post. So the question is how you need to this line 1 and line 2 you need to traverse it. Now from the first you will get your first pointer, and from the second you will get last, you will get the last pointer. But you need to, you see each one of here is previous is your uh, shared pointer, and weak pointer, and next is your shared pointer. So that's the reason how you will write your traversal. So shared pointer t is equal to first, t not equal to null, t is equal to take next. Fine, because it is shared pointer, no issue. Now the next one is your weak pointer. So this element, this previous is equal. So you write weak pointer node t is equal to last, auto p t is equal to log. So you are saying you need to convert it into your a shared pointer, because in this case whatever is being pointed to by t is basically a weak pointer, and then you say p is equal to p next, p pref. So that is how you do. Yeah, fine. If I am active, I can reply. Okay, that one. That was the end of the lesson. Best of luck for the exam. Thank you.